I bet that almost no die is honest. I've been suspicious of this for a long time, and today we're going to put it to the test. Roll the die 10,000 times to see if there's any bias here. To start with, what exactly is an honest die? Is it one that pays its taxes on time, that always tells the truth, that doesn't cut in line? An honest die is one where the chance of rolling a 1 is the same as rolling a 6, where the chance of rolling a 5 is the same as rolling a 2, and so on. It's a die where the chance of getting one number is equal to the chance of getting any other number. It's a die that truly gives a random result. A die that won't favor any number, that won't land on one number more than another. The thing is, I don't think this happens with these more common dice. I do think there's a problem with it. And the tendency is that the number 6 comes up much more often than the number 1. So, before anything else, let's understand exactly how a die works. Right? How are the numbers arranged here? The 6 is on the side opposite to 1. And whenever you add the two opposite sides of the die, it will always add up to 7. So the 6 is on the side opposite to 1, which adds up to 7. The 4 is opposite to 3, which adds up to 7. The 5 is opposite to 2, which adds up to 7. Every die is the same, okay? That doesn't change. But up to here, everything's fine. That doesn't make a difference in the chance of one number coming up or another. The problem is that most of these dice have little holes. The numbers are marked with holes in the plastic that forms the die. And these holes can actually affect how the weight is distributed. And now Allison is eager to explain to you how the center of mass of the die works, which is the point of balance there.
Every object has a center of mass, and the center of mass is the balance point of that object. When I can balance this stick, it means its center of mass is right above my finger. It's right above the support point. If, for example, I increase the amount of mass on one side, if I add more weight to one side, the center of mass changes. It gets closer to where there is more weight. A cube, for example, has its center of mass right here in the middle. But there's a problem. Dice have holes, and those holes remove material from them. So, if I have a hole on the bottom and 3 holes on the top, the center of mass will go down. It will get closer to the region that's heavier, just like it happened with the broom.
Now imagine this, the moment you throw the die. Won't this off-center of mass, which actually happens, have any influence? I think it will. Allison was actually pretty nice in his drawing here, and put a hole on this side and 3 on the other. But on the actual die I have in my hand, on the opposite side, we have 6 holes. So, the weight difference between one side and the other is really big. Could this really not affect anything when we roll it? I think it's impossible that it doesn't. It will definitely have an influence. What I believe is that the tendency for the number 6 to land face up will be much higher than for the 1, because the 1 is heavier. My suspicion got even stronger when I saw this die here. Look at this beauty. A transparent acrylic die. Super symmetrical. And I paid 50 Reis for it. This is a professional grade die. What does that mean? It's used when people are competing for something that involves money, where there really can't be any bias or any problem with the die. How is it different from the other one? Besides being prettier, this die does have holes, but the holes are filled with white material. So, in the end, it's a very symmetrical die. It doesn't have any cavities, and just the fact that it exists is already a big clue that the other die that comes with the games we buy every day isn't that reliable. So, the idea here in this video is for us to do the test. We'll be able to compare the performance of a supposedly professional grade die. That's perfect, with an ordinary everyday die, but there's still a third type of die I wanted to test, which is the rigged die. The one that's made to be unfair. The loaded die. I couldn't find this kind of die to buy, so Allison is going to make a die like this. The idea is to intentionally put more weight on one side than the other, so that the die really lands on the face we want.
Now ask me to rig the die, and there are several ways to do it. We'll use the usual method. Make a hole, add a dot on the die, and add weight. In this case, we have the die, and we're going to use little pieces of nail as weights. Usually, people put the weight on the side with the number 1, and that makes the number 6 land face up more often. But since we want to exaggerate the result a lot, we want to go overboard. We're going to put 6 weights on the side with the number 6 to make the die. First, we're going to drill 6 holes in it using the drill here. So we took a 3.5mm drill bit and using the drill press, we made the 6 holes. Ele usando aqui a furadeira, and a little bit of glue was put in each of the holes. Right after that, we put a small piece of nail in each hole. To finish, we put a little bit of glue in each of the holes. Right after that, we added epoxy putty, which is that putty where you mix part A with part B, and after some time it hardens. We covered the surface of the hole and used the nail to finish by making a detail there, so it would look like the sides that weren't modified. And to finish, we're going to paint the little holes black.
It's time to start this test, right? You can probably already guess who's going to roll the die. Look, here's the board. The idea is that as you roll the dice, you mark it on the board. Like if you roll a 2, you put a tally mark on the 2 here, and you do this 10,000 times.
10,000?
Of course, 10,000. Why play that many times? If we roll the dice like 10 times, or even, I don't know, 100 times, we can't really tell if it's loaded or not because the numbers are random. One number will likely appear often, the other only a few times. The more times we roll the dice, the more reliable our results are, kind of like an election poll. You can't just ask 3 people on the street who they're going to vote for because you won't get a meaningful number that way. Polls ask thousands of people to get numbers that are closer to reality. That's what we'll have to do with the dice. I think 10,000 is a number where we can already tell if the dice are biased or not. Deal.
Deal. Can I at least take a lunch break?
Well, yeah, the idea is that by the end of the day, more or less, no, by the end of the day, there isn't enough time. But anyway, good luck.
All right, well, let's get started, right? I don't think it's going to take that long.
Hey, Allison's it working out?
I lost count.
You didn't really think I'd make a listen. Roll 3 dice 10,000 times each, right? I considered it, but after doing the math, I realized it would take days. What we actually thought about doing here at Manual do Mundo was building a robot that rolls the dice and somehow have a computerized way to read the dice so it wouldn't be so much work. The issue is that using a robot like that could be more work than simply rolling the dice ourselves, and that's when we had the idea to invite someone I've wanted to have in a Manual do Mundo video for a long time. Jay Barbosa. A really awesome guy who makes all kinds of robots, and I think he could build this dice launcher in a day. Hey Barbosa, you can look up his profile on Instagram later. Hey G, how's it going? Look, I have a kind of complicated proposal here, and we need a machine that can roll a die at least 10,000 times, then take a picture of the die and store it in memory so we can know how many times each number came up in those 10,000 rolls. Hey.
All good. While you're explaining what needs to be done, my mind's already racing with ideas on how I could make it. It works, I accept the proposal, we can work on these.
Hey Barbosa. Welcome, man. Man, I've been following you for a long time. All the things you do, and I get jealous because I don't have that robotic skill you have. Man, congratulations.
Thank you very much.
I wanted you to show the small device you brought. It looks like a 3D printer.
Yeah, more or less the parts were taken from there. There's a stepper motor, there are pulleys here, just like in a 3D printer.
Okay, how does it work?
The first thing that needs to happen is the die has to be rolled.
Okay, now you need to read this result on the camera.
Exactly. Now that's where the other part of the circuit comes in, which is closing the flaps. I have a circuit here that will close the flaps to bring the die to the center first, and then it will be rolled in here, where the reading is done with a camera. And in here we have a disassembled webcam, where there's a sensor that will identify which face of the die is up. So, at no point while it's here will it turn. So, it stopped.
On 3, it rolled, landed on 3.
It landed on 3, so it'll register as 3 here.
Okay, the goal of these little tabs is to collect the die for the camera. Exactly. To fit the die under the camera without flipping it.
That's it. Then it stops right here and reads. From here, this motor will already be down here, waiting for the die to arrive, where we have a cup that will determine the die's next phase. It's going to come in here with this little tab. It's going to push it inside. This motor will go up. This little cup will be facing up, spinning here to move the die. That's basically it. That's one.
It's like when the guy has the little cup in his hand.
It's the small cup included with the casino die. As soon as he moves it, he's going to turn it upside down and roll again. And like that, the whole cycle starts over again.
Okay, now I want more details about what you did here. First thing, what's the brain of this thing?
It's an Arduino Nano, this little board right here in the front. It's what controls all the motors, all the sensors, except for the camera that's connected directly to the computer. Okay.
Let's go. This motor does what I found most interesting here. Well, two things, right? One is that you can position the die, and the other is that you can pick it up again and throw it.
At first, for the sweeper, I thought about making something like a closing gate, but it would need more parts in the back, more parts over there. For it to close like a gate, there would be excess material and the machine would be oversized, right? So I used a belt system with a motor to close both flaps simultaneously in opposite directions. So to come up with this idea, it was a little jumbled in my head, but I managed to figure it out. There are two, actually there's one. Belt that will rotate, and as one side of the belt comes, the other goes. So you get the movement of each one, so it'll make this kind of movement.
It's hard to understand when you explain it that way. Can we turn it upside down here to understand this belt? Yes, we can. Man, it's just the motor here. Look, that's making all this movement. This is amazing. You made this whole 3D part too. Everything.
I modeled everything myself. There was something else I wanted to do, but didn't want to use too much space. So instead of making something rigid that would move here in the middle, I made something flexible, because no matter if it hits here, it won't jam the motor.
Okay. You don't have a blade that keeps moving back and forth here.
Exactly. I considered making a roller here that spins like a tape measure, but I forgot that a tape measure uses a spring to retract. So it ended up with this movement where it's going to do this motion here. Look. And here it stops the die to do the reading.
So here you have a kind of little gear that pulls this flexible strip.
Exactly. There's a pulley made of this same material, TPU, for added grip. It's basically rubber, right? It's like a car tire rolling on this other belt that's made of the same material. Then you go back and it comes back here.
Okay, that's already the second little motor of the machine.
Exactly. It stopped here. It's going to do the reading. Let's lower this motor here so we can see. Let's do it. Up here, there's another motor that's going to lower the machine, which is
elevator.
Yeah. On the side here, we have two servo motors that will make this movement here, look, of lifting and lowering. It will be in this position, and as soon as the die enters here, it will lift the head. From here, it will lift the die up so it can start spinning and be thrown again. It stops up here, then it will start spinning the head. After this spin, it throws the die. Okay, what happened? The die fell out. We need
a guard so it doesn't fall. It's falling. A guard, that's right.
Okay.
See, it was already thought of.
Everything is already programmed. Yeah, we have here an acrylic box
That won't let the die escape.
that protects everything. So it falls here inside the enclosure.
This is the random moment, right? This is when it happens. When we think the center of mass will matter.
Exactly.
Here we go again, it landed, and it starts all over again.
Here he starts the cycle again.
And then we have, and this is the mechanical part of it, right? So counting here, I counted 6 motors, is that right? 6?
6 motors.
6 motors. Besides all this, 3D dice rolling printer. There's also the software that can read the die. See what the result is and keep track of it, right? It accumulates there for later results, so we don't need anyone watching it, right?
Taking a picture to save it. 24 hours? Exactly.
So how did you make the program?
The program was split into 2 code types. C++, which is a programming language for Arduino. That's the language the Arduino understands. And Python was used for the camera, so the computer can read the camera to identify which face it is.
Okay. And tell me something, how long does a full cycle take? From picking up the die to rolling it and reading the result?
Just 15 seconds.
15 seconds. Now we're going to have to do the math here. Hold on. Let's see. 5,760 rolls per day.
Exactly.
So if we want to do about 10,000 per die, it's going to be about
40 hours.
Okay. That's actually pretty fast. If a person were doing, that would be a week's work.
Your hand would give out and you'd strain your eyes.
Yeah, no. There's no way. Now, we're going to take this machine and put it to work for real. We'll leave it working here for about 10 days, testing all the dice. Let's hope that the guy made a machine that can handle it, because, you know, I have a habit. I have a really bad habit here at Manuel do Mundo. I'm really heavy-handed. Do you know what that means?
The machine breaks down halfway through. Yeah?
Everything I touch breaks, because I'm kind of rough. So I'll try not to be clumsy with your robot so I can give it back to you in one piece. This way, you can use the parts in other projects, which, by the way, are all recycled.
All recycled. Many parts here were taken from the junkyard.
Look, for anyone who wants to know more, about how this was made. Jay puts everything on his channel. Just follow D Barbosa on Instagram. There are a bunch of other crazy machines he's already made there. Thank you. Let's test your little machine here. Let's go. Now I want to see it working. The first test will be done with the regular die, with the drilled die. And what's the setup we put together here in the room? I set up the laptop, the robot, and next to it, we have a big power bank here, which means that if there's a power flicker, the robot will keep working. The laptop, of course, has a battery, but the robot doesn't, and it loses its settings if the power goes out. Another important thing is that we need a lot of lighting here so it can read the die properly. It's not this light you're seeing here. We'll have to turn on a light right above, where the die is read. And the idea is for this to run for about 2.5 days of testing, which is the necessary time. And I'll be honest, I'm really nervous about whether this little robot will hold up because it's a lot of cycles. It's repeating the same movement many times, and that wears out the parts. So it's possible that it might stop halfway through. And then I don't know what's going to happen. Let's go. Let's start. I pressed play here. I need to see if he's reading the numbers right with the light we set up. Maybe someone will complain that doing this with a robot makes the movement no longer random, because the robot does exactly the same movement several times. It's true that the robot takes away some of that, but we added several movements here to make it more and more random. Take a look. The first thing is this spin, which is pretty intense. It makes the die spin twice. Then it spits the die out. Sometimes it hits this support, sometimes it doesn't, and it still falls and rolls. Proof that this isn't being repeated, that the movement isn't always the same, is that the die falls in a different spot each time. We've already had a problem here. Look, it ran 540 cycles, 540 times, but this belt underneath, it slipped off the motor here. Look, it slipped off on both sides. This is loose. Yeah, it's not going to be easy. We need to do some maintenance on the robot here so we continue. I've already sent a message to Jay. He already explained to me how to do it, but making this thing run 10,000 times for each die is not going to be easy. I think it's working. I'm going to pause to show you another little problem that's happening here. Want to see. Eye is getting dirty. Look, its faces are getting really dirty. Some gunk is sticking to it. I don't know. Maybe it's dust or whatever. But this messes up the computer's reading because look when it looks at this. Number 1. Here, it might read this little smudge as if it were a 5. I don't know. So I have to clean the die so it can keep going. Jay left the machine with us working just fine. But the moment we really started running it, it started having problems. It wasn't a certified robot that had already passed all the tests. So we found out that when you stress the machine, when you really make it work, some things start to go wrong. The problem is that it went even worse than we imagined, to the point where it would have been easier to just roll the dice by hand than to keep fixing the robot that rolls the dice. And we had to send the robot back to him, this time by mail, so he could test it there, because after all, maybe the son works better near the father, right? Let's see what Jay is going to show us.
And once again, I have the machine. I've already tested it, and everything is working. Apparently, it was just nervous about being alone with Iber, Mr. Heavy Hands. Just kidding. The machine really did have some problems, and I'm going to show you what I did. The main modification was replacing the motor that pushes the die forward. The original motor couldn't handle quick changes in direction, causing a lot of wear on the inside. And the second thing I did was make a small change to the code. I made it lighter, reduced the machine speed to prevent the Arduino from freezing. Well, now with the machine working 100%, let's finally move on to the test. I positioned the machine, connected it to the computer, and let's test the first die. And here goes the first roll.
About 2 months later, we have the first result, which is from the professional die. Let's do some data analysis. This one is nice. It has 6 sides. This one is green. This one is kind of yellow. Yes, there's pink too. I like the green one. That wasn't the type of data analysis I meant. If we rolled a die 10,000 times, and each side landed exactly the same number of times, we'd have 1,666 times the number 1, 1,666 times the number 2, and so on. What did Jay achieve? He achieved that with the robot and the professional die. It's very close to that. So, you can say that each face of the die landed almost the same number of times. Yes, it's a very precise die, and it's really cool because it makes sense. Right? The die is made for that. It also means the machine isn't rigged, right? It worked. Everything's fine. I'm curious to see the rigged die. But think about a die that we actually managed to rig for real. Look, the number 1, which was supposed to come up more often, came up 2,333 times. And the number 6, which is on the other side and was the one affected, came up almost half as much, 1,218 times. Among the numbers that aren't biased, we had more or less a tie here. It stays pretty stable, so that means, once again, the die behaved exactly the way we were predicting it would behave. Really biased die, it lands on one way more often than on 6. But what about the regular die? And what about the doubt I had in the back of my mind, huh? Is it really a fair die? Or does it actually land on 6 more than the others? Man, look at this graph here. Number 1 came up 1,546 times, which is below the average number there, right? Which is 1,666. 1,666. Number 2, 1,623. 1,623. 1,654. It forms a little staircase until it reaches number 6 with 1,770 times. Number 6 came up a lot more times than number 1 exactly. Exactly the way I had predicted. Yes, the die is biased. And we've discovered something else here. Not only does the number 6 come up the most, but the higher the number, the greater the chance it will come up. And only after seeing these numbers and looking at the die did I realize that this makes perfect sense. Take a close look. Imagine the die is in this unstable position here, okay? It's almost falling to one side or the other. It's teetering between 2 and 1. Which one will land? It'll be 2, because 1 is heavier, or if it's in this other situation here, between 5 and 4, which one will end up on top? 5 will be on top because 4 is heavier. Or if it's in this other situation here, between 6 and 3, which one will end up on top? 6 will be on top because 3 is heavier. The smaller number is always heavier than the larger number, so the smaller number always tends to stay at the bottom, and the larger number tends to stay on top. And that's not all. I found out that the same phenomenon happens. It happens on the bottom part of the die. Look how crazy that is. If it's here, unstable and about to fall, between 5 and 3. If I look under the die, I'll see the number 2 and the number 4. The 2 is next to the 3, and the 4 is next to the 5. In other words, the heavier one, which is the 2, is next to the 3, which is also heavier. So, the entire half of the die on this side is heavier than the entire half on the other side. And this always happens. It happens in any combination. 30,000 die rolls for us to figure this out. If this video isn't worth a like, I don't know what is. And of all the experiments we've done on Manual do Mundo, the most famous one, the one people liked the most, was when we tested if a light bulb really burns out. If you turn it off and on thousands of times, and we turned the light bulbs on and off way more than 1,000 times. It's worth watching to see the final result.